All right. Can everybody hear me? Cool. That's perfect. Yeah, so continuing our talk from last week about career fair, we're going to be talking about networking. So we're going to be talking to each other this week. Isn't that so much fun? I'm lying. We're talking about actual networking. I'm lying. We don't have to talk to people this week. All right. Who am I? I'm a fifth year BSMS. Not as old as Anthony, though. Let that be known. I currently work for the Department of Homeland Security. I was the former ISDSCA, the former CTFCA, a former CCDC member, and about to be a former Red Teamer. All right. So, why do we talk about networking? It's important. Everything that you guys do, all the fun things you want to do, you want to run your little C2, you want to work on the internet, you have to use networking to do it. It's boring. I know. Nobody likes it. Other reasons as well. How does it work? Physical things. That's gross. This is also a live look into the server room. I know. That's like tech. It's actually a live look into tech crew stuff. So, yeah. So it's networking has to run through wires. It's like if you want to go across, access the UK government website, there's a fun undersea cable that runs all the way across the Atlantic that connects us to them. So, and there's also a lot of embedded programming that takes place as well that makes networking be able to work. So, the OSI model, so much fun. Everybody loves to hear about it in routing and switching and network services and every other networking class you take here. There's 7 layers. You only care about these 3. I'm going to cover each one, but you really only care about the application layer, the transport layer, and the network layer for you guys. So we start at the physical layer. We're going back to wires. So we have Ethernet cables. We also have white, ooh, fancy. It's the new thing that's been around for like 10 years, but still the new thing. And then you have the physical actual routers and switches that are placed throughout the country at switching ports, destination hubs, ISPs, things like that. Then you have the data link layer, which is going to be, so that's the LLC, which is a logical link connection. So that allows all the network protocols, which there's dozens of, to all use MAC addresses. So what is a MAC address? A MAC address is a, 6-octet unique identifier that's given to every single device that has a NIC. So the first 3 octets has to do with the actual manufacturer. Those are given by, I don't remember who gives them. It's given by a government agency to certain manufacturers, and they all have a pool of them. And then the last 3 octets is going to be the actual identifier for the NIC itself. And then finally you have ARP. And ARP is a specific network protocol that is able to link IP addresses to MAC addresses. And that's how everything communicates, is you have to figure out which IP address links to which MAC address, which links back and forth. A NIC is a network interface card. Other question. Why do we have both what? We have both IP and MAC because you can have many devices that all have the same IP address, like private IP addresses, but every one only has one specific MAC address. So it allows for multiple devices, if for some reason they have the same IP address, as long as the MAC address stays there, we know where to direct it to and we know where to go. Cool, the network layer. So this is where you get your IP address. So it's a 32-bit network identifier. Each one is split into 1 byte. So it's a maximum of 255 for each one. So you can have 255, 255, 255, 255. That is a broadcast for everything. Nobody ever uses that because you should never do that, but it's the broadcast for a lot of things. On this level, there's also a lot of packet fragmentation. So it splits network packets up into different segments, which allows you to communicate across different devices. If there's different settings on the device, it doesn't drop packets when it's not helpful. And network packets are the little is just your data that's being sent across. So, and you have ICMP. You guys should all ping that address. It's really fun and doesn't link anywhere specifically. It does not link to the NSA website. So, yeah. So ICMP, or ping, as it's commonly known, is a great way to test if you have network connectivity. All it does is it sends a packet out to the device and then it replies back. So if you, for some reason, can't access something on the internet, I would try pinging 8.8.8.8, which is Google's DNS server. If you can't access that, you're not hitting the internet and you have a bigger issue on your hand where your device isn't able to reach out. Moving on. So here we go. Here's the big discussion when it comes to the network protocol, is IPv4 versus IPv6. IPv4 is awesome. It's amazing. IPv6 is useless and should have never been invented. And anybody who complains just doesn't like to use natting. And that's it. Lucas. So, yeah, so there's actually a significant difference. So back to this slide, this address you see in the top right corner is an IPv4 address. It's just 4 1 byte split up by periods. It's nice and simple. It's a lot easier to remember. If you remember what the MAC addresses look like, that's what a lot of IPv6 addresses look like. They're very complicated to remember, which is why they have not been adopted, even though they've existed for 12 years. So a lot of people feel as though IPv6 is kind of useless. RIT actually uses a few IPv6 addresses for, I believe, their main website is actually an IPv6 web server. So, yeah. All right. Now, why has IPv4 not been removed and kicked out? It's because of natting. Because there was a problem 20, 30 years ago where we realized, oh shoot, this internet thing is popular. We can't give everybody an IP address because we're going to run out of IP addresses because we only have like a million something. And I think right now there's billions of devices connected to the network. So this protocol was invented called natting. So it ended up saving IPv4. It allows for many different IPs to use one central IP. So you have, on your home network, you probably have a few devices when you go back home where you have, your computer, your parents have a computer, you have your phones and stuff, but they all sit on the Wi-Fi network. You all don't have a public IP address, or you shouldn't all have a public IP address if you go through a typical ISP. Instead, what you do is you all connect to the router that the ISP gave you, and that router itself will most likely than not have an actual public IP address. Other times, some ISPs will NAT those routers behind their own network, but yeah. So this allows for many private addresses, which is your 192.168, your 10.0, to sit behind a router and use one publicly facing IP address. So you can still use the internet, but everybody is not having the same IP address, and you have a lot of conflicts there. Ports. This is another very important part of the networking section. It's essentially a bunch of networking holes inside of your computer or your server. So notable ports include port 22 for SSH, 23 for FTP, things like that. So these are specific protocols, and specific services will use very specific ports. There's also a range of like 25,000 or something that are just open for any service to use. So your video games will a lot of the times just use a random port to just use connections. So yeah, that is actually the picture there, not a networking port, not technically, not what I'm talking about here. Networking ports are entirely invisible and they only exist on the networking level of the OSI model. All right, now we get up to the transport layer. I need somebody to stand up. I need Garrett to come stand up and stand over there. So what's up? Your device. So the question was, where do ports actually connect to? Ports connect just to your device. It's just a way for ports to, like service. What? Because you need to know where to go to access specific things. So if your hardware is running and listening on a very specific thing, the service needs to be able to connect there. You can't just all connect to the same IP address because all the packets are going to get confused and not know where to go. So that's why ports were invented or used. So the packets are going to your device, right? So you connect to a web server. You send your packets to so you send a connection, or in this case, I'll talk about that in a second. You send a connection to the web server. The web server will send something back. Most likely than not, it's going to be an HTTPS packet, and that's going to enter on 443. But if that was entering on other things, your computer and your network interface would be very confused on where to direct that to on your like kernel or operating system. So it then gets lost, and you don't know what's supposed to be accessed. All right. Can I have a marker? Does somebody have a marker I can use, or a pen, or something sharp, preferably? I'll take a pen. Oh, perfect. 2 pens. 3 pens. You might get it back. All right, Garrett, do you know what's happening? Oh, perfect. So Garrett knows what's happening. Garrett, what are we doing here? Are we talking about? We are doing a very wise presentation. All right, so we're going to talk about, there's 2 protocols that are used for TCP for the transport layer, TCP and UDP. There's others, but those are the main 2. So TCP, it requires something. It requires a specific handshake. So what you do is you send a packet over to somebody else, some sort of initialization request. They send it back to you with an acknowledgement, and then you can make the connection. It's great. It works great. It's great for like the web server, the website I was talking about. That's how you make connections between them. So it's a very stable connection. There's a lot of things that are put in place inside of TCP to make sure your packets are going to and from your device to whatever service you're connecting to. However, there's another protocol called UDP. UDP does not care. All it does is it just sends packets at the device and just keeps sending them until it transmits everything it does. There's no error checking. There's nothing. Do not take those pens. Give those back. Yeah. Don't throw the pens. Just give them back. Yeah. Yeah, send a packet, Garrett. So TCP is a lot used for a lot of sessions and things like that. So connecting to a website, SSH, I believe uses TCP, and things like that. UDP, on the other hand, you just send packets. You just send information until you do what you need to do. A lot of online video games nowadays just use UDP. That's why when you're playing and you lag and it says like, oh, there's a packet dropping and stuff like that, that's what's happening. Your packets are just getting lost and the game's just not going to do anything about it, so you might get kicked out of the game. So yeah, a lot of fun stuff. The session layer. This one's so much fun. I'll wait a sec. You guys can read the slide. No, it's actually useless. You guys don't need to know anything about it. It's all the logic is handled without you guys. There's nothing you will ever have to do with this layer at all. Oh, but what about the presentation layer? Same thing. It's entirely useless. It's already done by, all the logic's already been figured out 20 years ago. There's no real need for you to ever try to interact with that. It's all been handled. A lot of applications and the application layer handle those 2 parts for you, so you don't ever have to interact with them. Yeah, so the application layer is the fun layer. This is where everything happens nowadays. Everything is handled through the application layer. You're using a web browser, that's through the application layer. You're using any sort of device with a GUI on it, you're using the application layer. You're using the command line 90% of the time using the application layer. So, what are some other fun networking things? Firewalls. If you're blue teaming for RITSEC, which will be dropped later today, or you want to blue team in general, learn what firewalls are. They block IPs and or protocols, so you can block specific protocols from specific IPs, things like that. They're very, very important if you want to kick red team out of your box. So, or in the case of CCDC, lock yourself out of your box. I will tell you right now, do not block SSH on a cloud box. If you block SSH on a cloud box, you have locked yourself out of that box. Everybody does it every year. Yes, Justin? Another thing is do not disable your network interface card on your cloud box because that's what the CCDC team thinks is a good idea. Yeah, so firewall is very, very useful, very helpful. You can kick a lot of red team tools out if you use firewalls. However, be very careful because they're always they don't care where it's coming from. If you tell it to follow a rule, it'll follow the rule and it'll block yourself sometimes as well. The specific firewall depends a lot on the system itself. So for Unix systems, it's IP tables or UFW, which is uncomplicated firewall. Windows just uses Windows Firewall. It's kind of okay. And a lot of network devices will use PFCTL, or otherwise known as packet filter. Yes, Adam. It kind of depends. A lot of them are implemented at the network layer, but a lot on other devices, it's also like if you have a firewall on the router, it just scans the specific packets coming in and it'll drop them depending on the rule set. So yeah. So yeah, firewall rules are very important. They're a lot of the times they'll be on your router itself, but your systems as well have them, and they can be very useful on your systems as well. They usually will end up blocking on your network interface, so whatever Ethernet port you have is where it will be blocked a lot of the time. Now we have some fun networking commands that I'm telling you for no specific reason. We have netcat, we have dig, we have netstat, and curl. So these are all very basic, very useful networking commands that you can use to kind of play around and sort of visualize networking. So first up is netcat. So all of you should be familiar with the cat command, which is just reading a file and printing its output. Here's how you do that over the network. That's really it. It's just used to read and write from different connections that you have. So if you want to listen for a specific connection, just do NC-L-P and then whatever port number you want to sit on. Pick your favorite port number. A lot of people will just do 8.8 or 8888. There's also wheat is another favorite of people for no specific reason. And then if you go on another device or even on your local host, you can just do NC localhost and then that same port, and you're able to send commands to and from your own device. Same with, you're also able to send a file using this command as well, because it's the cat command. Dig, what's up? Firewalls. Can you repeat that? I'm not familiar with unified threat management. Is anybody else and would like to explain it to me? Oh, the question is, how are firewalls implemented in unified threat managers? I'm not familiar with unified, yeah. We can talk about it later. I'd love to have a conversation about it. I just am not familiar with that. Okay, moving on. Dig. So this is how you query DNS servers or domain name service servers for IP addresses attached to the fun little host names that you have. So if we remember when I pinged the NSA.gov site, it popped up with a IP address. This is how you'd be able to find that IP address. So you can just do dig nsa.gov and it'll give you a few different IP addresses that you can use that are associated with that specific name. You can specify a DNS server. So if you put up a DNS server on your local device, you can query that and any specific DNS you've set up. You can use that to actually check and verify that it's working. And you can specify like MX records, AAA records, things like that. Yes, Adam.
Feel free to stop me at any point, by the way.
Do you want to hold a lot of these questions till the end?
Yeah, that's a good.
Okay, we're going to hold a lot of your questions till the end. You're fine. All right, then we have NetStat. So you know how we did Netcat a little bit ago? So NetStat is going to be able to display those connections that you're creating through Netcat. It also is able to display every connection that's sitting on your device. A lot of these are going to be primarily on Linux machines. Windows is its own beast and has a lot of just Windows tools that you can do that they talked about in previous weeks. But NetStat is going to be able to display any sort of connections that you have. So if inactive, actively listening, active connections, all of that are going to be displayed by NetStat, and you have a lot of different modifiers you can put on to see those different connections and kind of filter through them, because a lot of the times it will just be a lot of information. And then curl. So curl, all it does, gets the contents of a URL file. So if you want to go curl any number of sites, it'll just dump the HTML of that site onto your command line. You just curl using a URL. You can save the contents to a file, or you can, if the website follows a lot of redirects, just use TechL and it follows those redirects and grabs the final content. All right. Finally, we've gotten to Wireshark. So much fun. If you like staring at 35,000 network packets that I've captured by sitting on the RIT WAN for 5 minutes, yeah, it's a lot of fun. It's actually a very useful tool, especially when you're doing any sort of investigative network work. It allows you to see all the packets that are passing through your NIC. So a lot of you should be on EDU Roam. If you have Wireshark installed, which some of you might, just spin that up, listening on the Wi-Fi, and you will just see thousands of packets within seconds, because it's all the different broadcast devices that are sitting around and a bunch of broadcast connections. They're just spitting out packets. So here, the first one I picked up when I started listening on Wireshark was this device sitting at a 10 dot network that was just broadcasting for trying to find something. What was it specifically? It was somebody trying to connect their iPhone to Disney Plus. I don't know why I could see that, but yeah, there's the public key they're using to try and connect to their Disney Plus account. So it's fun. This information is entirely useless, but yeah, you can see a lot of different things, especially when you have a public IP that RIT gives you when you're sitting on EDU Roam. You just see a lot of stuff that's happening. Question. Yeah. The question was, are you allowed to use Wireshark in the RA2 Wi-Fi? Yeah. I mean, you're just sitting there looking at connections. There's nothing bad about Wireshark. You can't do anything nefarious with it. If there's information being transmitted that you can see on Wireshark that you shouldn't be seeing, then that's a them problem, not a you problem, because they probably shouldn't be transmitting that data. Question. I can't hear you. I'm sorry. What quick protocols? What are you talking about? Mm-hmm. Um, I don't think there's a lot of differences between the two, as far as I'm aware, but I haven't done a lot of investigation because DNS is just so prevalent throughout. So as far as I'm aware, there's no significant change between the two, but it could also just be like some other protocol that piggybacks off DNS or something like that. All right, so how do you actually use Wireshark? So when you load up Wireshark, you're going to be asked which NIC you want to use. So depending on what computer you're using, for mine, I have a lot of VMware network adapters. a lot of LAN connections for some reason, and a lot of other stuff. Yours is probably going to have a bunch of other options. You just pick one of those interfaces. You probably want to use your Wi-Fi card or your Ethernet port or something like that. It'll show you a graph of the traffic in that little box, so you can see which one is actually being used and which one's just kind of sitting there not doing anything. Once you click that, you just start receiving packets. So here, I was just sitting there for like 2 seconds, and I've already gotten 50 something packets out of this. And here's just the screen that you're launched in immediately. So up top, you see these three. The most important are going to be these three buttons. So the one on the left that's grayed out, that's going to be you're going to start capturing packets. The red button right there is going to be stop capturing packets, and that green one is going to be to reload and refresh. So going back here, that's just up in the top left. You're immediately going to start capturing packets, so I would recommend you hit stop until you're ready and have played around with it, because otherwise it's just going to be dumping thousands of packets onto your screen. That makes no sense. Another thing is right underneath those, there's a display filter you can do, and that you can filter by anything. Protocol, so you can filter by TCP UDP, you can filter by IP address, you can filter by ICMP, any number of things you can use to filter there. Next up is the bottom part of the screen. So here is there's two different sections. So on the left is the packet broken up into its different sections that is used by the OSI model. So you have the application, you have the transport protocol, you have the network protocol, you have the data link protocol, and then you actually have the actual frame of the entire packet itself. And then on the right, you have the hex dump of the protocol all put together. So that's going to be all the data that's located on that packet. It's going to be sitting right there. You can expand the sections of the different network layers, so you can see whatever you want to see. So here, I expanded the IP and the TCP, so I can see the source port, the destination port of it, segment links. There's a lot of information here that's dumped that you're going to learn about in routing and switching and network services, but there's a lot also to play around with as well, and there's a lot of areas that you can actually embed a lot of data in. So looking at packets through Wireshark is a great way to see where you can store data and kind of transmit it if you want to do something secretive with it. And then on the right side, you have the hex dump, like I was saying. So here's all of the different stuff. And then on the far right, you see what it looks like in ASCII characters. It's split up a little bit because it just gets split up depending on what data is actually sitting in there. But you can, as you hover over different pieces, it'll show you which part correlates to the hexadecimal as well. Cool. All right. Moving on to our final part. Yippee, pfSense. If you're going to be blue teaming at all with any competition we run here at RITSEC, and if you go over to University of Buffalo and a few other comps, they use pfSense. pfSense is a terrible operating system. You should avoid using it whenever possible. It's really, really bad. It's FreeBSD with another operating system sitting on top of that with PHP and shell scripts to make it all work. It's really, really bad, and I don't know why they sell it to companies, and companies pay money for it. There's a community edition, so if it's something you want to work with, it's entirely free for you guys to use, but there's also licensed versions that company will pay thousands of dollars for. I don't know why. Yeah, and that's why I spent the past 3 years looking into it. Yes, Will. I mean, yeah, there's a lot of different routers. Sorry. Will's question was, how does OpenWRT compare to pfSense? So pfSense is owned by a company. There's also a community and open source version that's called OpenSense. Same thing, kind of just pfSense, but it's open source, so anybody can contribute to it. OpenWRT, you also have, what's it called? I can't remember. Oh, Palo Alto. There's a lot of other different routers and specifically managed routers that you can get from across the internet from a bunch of different providers. pfSense we use because it's the easiest to set up and it's the easiest to virtualize. A lot of the other ones need physical hardware to do, but it's kind of up to your choice. So if you end up building a home lab or you're at your house and you're older and you want to set up your own network, there's hundreds of different routing pre-made routers you can use, and I mean you can even just turn any regular Linux box into a router. It's not that hard. So it's at this point, whatever router you're using is entirely personal preference. But yeah, so yeah, I spent the past 3 years looking into it and breaking it, and I'll give you guys presentations about that. That's a lot of what I do for Red Team is actually specifically focused on pfSense itself and breaking it and making it not fun for you guys to use, but I promise I'll teach you how to do it. Yeah, and I have the GitHub for the pfSense bookmarked because I have to visit it so frequently because it's so terrible to try and look through the file system of pfSense. Cool. So how do you use pfSense? So you've just been dropped in the competition. You have no idea what's happening. Everybody's yelling at you to put up firewall rules. How do you do that? So there's two ways to access pfSense. There's the command line, which is a lot of fun, and there's a lot of nuances to it, and it's kind of goofy, but it's good to use and a lot better than the web GUI. And there's the web GUI. I'm going to recommend, if you have never touched the operating system before, try and go to the web GUI. It's the easiest thing you're going to be able to use. It walks you through how to do everything. You don't have to learn specific commands, but the only issue is it's all written in PHP, which means it's very, very bad and very, very unsecure. So it's very easy for people to break. So command line, you can access it through two ways. You can either do it through the console access. So if you're given console access, great. Otherwise, you have to SSH in, which is, you guys have been taught how to do that. So there's a default user on pfSense that's made off start, and it's called the admin user. The password is pfSense. That is the same for every single pfSense box ever. So you just log in with admin at whatever the IP address is, and then pfSense, and you get this screen. The screen's interesting, and if you ever use the console of pfSense, you're going to be staring at this screen a lot. This is a slightly modified version of pfSense, as you can tell, because there's typically no option 17. I forgot I did this and then screenshotted it and didn't want to change it. But yeah. So there's a few options here. So if you're SSH in, you can hit option 0 and it disconnects you from your SSH connection. Option 1 allows you to change the interfaces you have. So if you want to change your WAN and LAN interfaces, you can do it there. Option 2 allows you to actually assign the different interfaces IP addresses. So if you want to statically set your IP addresses, you want to walk through it on option 2. If you ever get logged out of your web GUI, you just hit option 3 and it'll reset your password back to admin pfSense. Now the admin user is tied to both the console and the GUI. So if you reset your web GUI password, you've also just reset your SSH password as well. So when you log out, remember that it's now default. Option 4, if you're in a competition, do not hit option 4. It will just reboot your box into factory default, and you've just nuked your entire team. Your team will be very mad at you if you do this. A lot of the time, I will go in ahead of time when we're doing red team deploy and just take this option away from you guys, so you can't do it, even accidentally. But yeah, that's only very useful if you're setting it up yourself and you mess something up. Option 5 is just rebooting, so you can just restart it. 6 pauses the pfSense box. 7 allows you to ping any box you want to. And option 8 is your shell. So that's going to be your command line that you use. All the options 9 through 16, you're not going to ever use. I'm going to be real. The only other one is going to be option 14, which disables SSH. Don't do that if you don't have console access. If you do have console access, great. Hit that button, because that means that red team's not going to be able to SSH into your box anymore. But if you don't have console access, you've just locked yourself out of that box, and it will kick you out immediately, and you'll know you messed up. But yeah, and then option 17 is not normally there. So if there is an option 17, somebody's messed with your GUI, or somebody's messed with your console at least. So you should probably investigate that. But once you get into your shell, you're in. Um, pfSense does not have other users by default on it. So when you get into the shell, as long as you can SSH into the box and you can get into the shell, you're in as root. It doesn't matter. It doesn't care who accesses it. You're in as root. It's really bad and it's really insecure, which is why you need to lock it down, because anybody can run whatever they want. Some notable directories and files inside of that, inside of the CLI is etc rc initial. So that's this entire page right here. It is a single shell script called rc.initial. You can just edit it and do whatever you want to it. However, be careful, because if you break it and you try to restart your box to access it, you will not be able to restart. You will not be able to access that box anymore, because it will be boot looping trying to run a script that is broken. So be very careful editing it, but it's also very powerful. And if you notice option 17 there, that's probably embedded there. And I probably have done something to that box that you might want to go investigate using that RC initial. RC dot anything really. If you just type in etc rc and then hit tab, there's going to be a lot of scripts that pop up. All of those scripts are usually run on boot. There's like 30, 40 something, and they all run immediately as soon as the box starts up. So you can embed a lot of data in there. If you have a startup script you want to run, put it in that, or put it in one of those rc.initial files, and you'll be able to get a script that runs on boot. The final directory that I'm going to be looking at is user local www. This is where everything for the web GUI sits, and I mean everything. Every single web page you will visit in the web GUI is stored in this one directory. So if somebody moves this directory, your web GUI is now gone and has probably been moved to another location, and you should probably find it and move it back. I have done that before, so make a backup of your web GUI. Yeah, and everything sits there, and they're all PHP. And the final thing is cf conf config.xml. That's the config for your entire router. If somebody changes one thing on there and breaks that, your router is now broken if it ever restarts, because it will try to pull the XML file and will realize it's not valid and will just never boot. So protect that file and have a backup of that file as well. It's very important that you protect that. Yeah, like I said, easy red team stuff on top of what I mentioned before. If I have access to your command line, I'm going to shut down the interface. It's one command. It shuts your entire team out. It's really easy. It's just the ifconfig, whatever interface number you want to do, and then down. Would anybody like to take a guess on how you bring that interface back up? Jack Nardi? Wow. Yep. So to repeat that, to bring it back up, if I have shut it down, is ifconfig em0 up. If you notice that during a competition, your entire board becomes red, which means all your services are no longer connecting, I've probably shut off your network interface card. Turn that back on immediately. And then another easy one is just block all firewall rules. So I'll put this on your WAN interface. It'll just block every single packet that's coming in. And yeah, it'll do the same thing as if I just shut off your interface. So I just echo a block all statement into the pfctl that I had mentioned before. And then I just enable pfctl. Anybody want to guess how you disable pfctl if you're not using it through the command line? What's the first letter in disable? There you go. So it's pfctl tech D. So if you notice all your packets are being dropped or there's some sort of issue, red team might have messed with your firewall, and run tech D to see if that'll fix your problem. And if it does, then that means red team has added a firewall rule that you probably want to go find and get rid of. So we move on to the web GUI. This is what it looks like. You just go to the IP address of your LAN interface, and you'll be able to pull it up. So this is the initial screen. This is what it looks like. Like I said before, you have admin, and then it's pfSense for the password. Luckily for you guys, it auto tracks who logs in on the console. So if I am able to log in on your console and you guys didn't do that, it tells you when I logged in, where I logged in at, who I logged in as, and what IP address I logged in from. it just says all this in the console. So if you're SSH'd into the console and you notice these lines, but nobody on your team is logging into your GUI, somebody in red team is trying to access your GUI when they probably shouldn't be able to. So you should probably investigate that. But yeah, and then you just hit sign in and you're brought to the home screen. So here you have on the top, there's a bar with a bunch of drop-down menus, and that's going to be any and everything that the web GUI can do. So that's going to be using user managers, managing your interfaces, managing your firewall, the different services it can run. pfSense is also capable of running VPNs on itself, so you can connect to that VPN if you want. Status and diagnostic tools, and also just a help menu. So this is just the initial dashboard you log in on. There's not going to be any useful information here. You should start poking around. So here are some notable web pages. So first up is your user manager. You should almost immediately always go here because this is how you change your admin password. You should do this minute 0, is log in, change your admin password. It will tell you on the top if you have not changed the admin password and say it is set to the default value. So if you've changed your admin password and it is changed back to the default, it'll tell you and you'll know that somehow red team is in there. Also, red team will just make users on the web GUI a lot of the time, and they'll just pop up there. You should probably just hit that delete button and your problem solved. And yeah, so that's just that. You just hit the system button and then it'll drop down a menu and there'll be a user manager button that you can click. Next up is your firewall rules. So here you can do, depending on how many interfaces your firewall or your router has, it'll pop up with different things, but you can do either floating firewall rules, WAN firewall rules, or LAN firewall rules. You're probably going to want to focus on just WAN and LAN, and you can just, the buttons on the bottom right, you can add a firewall rule to the top, add one to the bottom, delete firewall rules, enable and disable them, or just copy them if you want to create multiple of them. And then you hit save, and then it'll apply the changes to your router. So you want to make sure that the firewall rules you're applying are to either your WAN or your LAN, because if you get those confused, you might lock yourself out of boxes when you do not need to lock yourself out of boxes. Underneath the diagnostics tools, there is a web page known as the command prompt. You would want to protect this page because this allows anybody who's accessing it to just run whatever commands they want to run as if they're root. So any user can access this page. So if red team has a user that's not admin and they log in with that user, go to this page and they can just run whatever command they want on your router. They can also download files off your router, upload files to your router, run PHP commands. They can kind of do anything they want from this page. This page is very important, and that's why the GUI is also important. So even if you don't protect your GUI, they can still do stuff. And then finally is going to be packet capture. So here is where, you know how I talked about Wireshark before? This is pfSense's built-in Wireshark. You can actually download packet captures that are run on it and open them in Wireshark and poke around them there. So if you are doing nothing and you're sitting around during a competition, have nothing to do, open up this, start running a packet capture, see if you notice any traffic that shouldn't be there. Just poke around. If you got nothing better to do, you're at least trying to threat hunt. Cool. Any questions? Besides Adam? Sure. What's your question? Like to split them up? I'll repeat it. So the question was, if you wanted to script looking through Wireshark captures, I know there's a built-in Python module, I believe, somewhere. I don't remember it off the top of my head, but Python's always a good one. I know on the Wireshark page, they should have some documentation for how to do it. But yeah, there's the information is also not like super encrypted and not super hidden inside of a PCAP file if you look through it through the command line. So I'm sure you could custom develop something on your own if it's something you really want to do. Any other questions? Adam, do you have any questions that are pertinent to everybody or a conversation? Okay, we can talk later. It's not that big a deal. All right, anything else? Cool. Thank you guys.